Welcome to RR Max. We'll continue with definite integrals, episode 3. I'm starting the fourth problem, which is again a standard problem. Evaluate the integral 0 to pi by 4 log of 1 plus tan theta d theta. As usual, I call the integral as I. So I is equal to integral 0 to pi by 4 log of 1 plus tan theta d theta. I use the same property of f of a minus x. So changing the limits, I now becomes I is equal to integral 0 to pi by 4 log of 1 plus, instead of theta I will use pi by 4 minus theta. So it is 1 plus tan of pi by 4 minus theta into d theta. Now this tan of pi by 4 minus theta, I'm going to expand using the formula tan of a minus b, which is tan a minus tan b divided by 1 minus tan a tan b. And a is here pi by 4. So tan of pi by 4 will be 1 because tan 45 is 1. So using that, I replace this value here as integral 0 to pi by 4 log of 1 plus tan pi by 4, which is 1, minus tan theta divided by tan pi by 4, which is 1, plus tan theta into d theta. This I will take LCM. So I am taking LCM with 1 plus tan theta. So the numerator becomes 1 plus tan theta plus 1 minus tan theta. Therefore, tan theta gets cancelled, leaving it as 1 plus 1, which is 2. So this integral now reduces to integral 0 to pi by 4 log of 2 by 1 plus tan theta into d theta. Now let's add the two i's. So I get 2i is equal to integral 0 to pi by 4, the first value, which is log of 1 plus tan theta, plus the second integral is log of 2 by 1 plus tan theta whole thing into d theta. Now this is log m plus log n, which can be replaced as log mn. So that reduces to integral 0 to pi by 4 log of 1 plus tan theta into 2 by 1 plus tan theta. So now 1 plus tan theta gets cancelled in the numerator and denominator. So the whole integral has integral 0 to pi by 4 log 2 d theta. Log 2 is a constant, so I remove it outside the integral. So you read it as log 2 integral 0 to pi by 4 d theta. So integrating this, we get theta and limits varying from 0 to pi by 4. So for theta, you substitute pi by 4 minus 0. So which will give you as pi by 4 into log 2. Now 2i is pi by 4 log 2, and therefore I is equal to pi by 8 log 2. So that solves this particular problem. Now we go to the fifth problem, which is again a standard problem. Fifth one, I is equal to evaluate integral 0 to pi by 2 log sin x dx. Now, as usual, I call it as I is equal to integral 0 to pi by 2 log sin x dx. Now use the same property and you substitute for x as pi by 2 minus x. So I is equal to integral 0 to pi by 2 log of sine pi by 2 minus x. Sine 90 minus x is changing to cos x. So you get this as integral 0 to pi by 2 log cos x dx. Now we'll add the two i's. So 2i is equal to integral 0 to pi by 2 log sin x plus log cos x. Again log m plus log n is log mn. So that reduces to 0 to pi by 2 log sin x into cos x dx. Now sin 2x is 2 sin x cos x. So I will replace the sin x cos x by sin 2x divided by 2. So integral 0 to pi by 2 log of sin 2x divided by 2 dx. Now this log m by n is being replaced by log m minus log n, and I change it as two different integrals. So integral 0 to pi by 2 log of sin 2x dx minus integral 0 to pi by 2 log 2 dx. Now log 2 is a constant, so when you integrate that, you just get x log 2. So minus the first integral remains as 0 to pi by 2 log of sin 2x dx minus x log 2 limits varying from 0 to pi by 2. you substitute the limits only for x. So here I substitute for x as pi by 2 upper limit and 0 for lower limit. So it reduces to integral 0 to pi by 2 log of sine 2x dx minus pi by 2 log 2. Now this 2x, I will make a small substitution. Y is equal to 2x. So dy is equal to 2 dx. Now limits has to be changed. So when x is 0, y is 0. When x is pi by 2, y is actually 2x. So you're substituting x is pi by 2. So 2 and 2 cancels to give you y is equal to pi. So your new limits for the new variable is integral 0 to pi log sine y dy by 2 minus pi by 2 log 2. Now this log is taken only for positive values. It's an absolute value of sine y and therefore it's treated as an even function, and so you can replace this integral 0 to pi as 2 times integral 0 to pi by 2. So this half comes out 2 times integral 0 to pi by 2 log of sine y dy minus pi by 2 log 2. Now log sine y dy is the original given integral, so we have called it as I. This 2 gets cancelled, so this reduces to I minus pi by 2 log 2. Now this side we had 2I and is equal to I minus pi by 2 log 2. So taking this I on the other side, you get 2I minus I, which is I, is equal to minus pi by 2 log 2. That's your final answer. We go to the sixth problem, which is a similar one. So evaluate integral 0 to pi log of 1 minus cos x dx. So I call it as I is equal to integral 0 to pi log of 1 minus cos x dx. Now for x, I am going to substitute pi minus x. So the new I is integral 0 to pi log of 1 minus cos of pi minus x into dx. Now cos 180 minus x is in the second quadrant, so it changes to minus cos x. So this will now change to integral 0 to pi by 2 log of 1 minus of minus cos x, so it becomes 1 plus cos x into dx. Now add the two i's, so you get 2i is equal to integral 0 to pi log of 1 minus cos x plus log of 1 plus cos x whole thing into dx. Log m plus log n is log mn, so that reduces to 2i is equal to integral 0 to pi log of 1 plus cos x into 1 minus cos x dx. Now this is a plus b into a minus b gives you a square minus b square, so that is log of 1 minus cos square x, and 1 minus cos square is sin square x, and so this integral now reduces to integral 0 to pi log of sin square x dx. Power reduction in log comes down, so that is 2 times integral 0 to pi log sin x dx. So now you can change this as it's an even integral, so it becomes 2 times integral 0 to pi by 2 log of sin x dx. So you have 4 times outside integral 0 to pi by 2 log sin x dx. Now this is the previous problem, so I directly quote just the answer here, but in the exam you are supposed to do the same proof fully completely here. So this reduces to 4 times. In the brackets you have minus pi by 2 log 2, which was the answer in the previous problem. So now this 2i is equal to minus 2 pi log 2, and therefore I is equal to minus pi log 2. That completes this problem. Now seventh problem. Evaluate integral 0 to 1 log of 1 plus x divided by 1 plus x square dx. Now here I cannot use this formula as x changes to 1 minus x, because in the denominator it is not going to simplify. So I will just make a substitution as x is equal to tan theta. So dx is going to be secant square theta d theta. So we have to change limits. So when x is 0, tan 0, so theta is 0. X is 1, so tan theta is 1, which means theta is 45 or pi by 4. So now the integral now reduces to integral 0 to pi by 4 log of 1 plus tan theta divided by 1 plus tan square theta, which is secant square theta, and for dx you write it as secant square theta d theta. The 2 secant square cancels, and reducing the integral to integral 0 to pi by 4 log of 1 plus theta, tan theta d theta. Now this you refer to the problem number 4 which we started today, and the answer there is pi by 8 log 2. So I have directly quoted the answer. The working out you can go to problem 4. Eighth problem is a simple one. So this is integral, evaluate integral 0 to 1 x square into 1 minus x whole power 100 dx. So here we use the property again and try to reduce the highest power to a simpler value. So 1 minus x power 100 cannot be expanded and integrated, which is difficult. So we'll try to reduce that as a single term. So you replace x as 1 minus x, call the integral as I. So integral I is equal to integral 0 to 1 minus x the whole square into 1 minus, for x I have put 1 minus x. So here x 1 gets cancelled giving you positive x. So this integral now reduces to integral 0 to 1 minus x the whole square x power 100 dx. So 1 minus x whole square can be expanded as 1 minus 2x plus x square whole thing into x power 100 dx. I have just used the formula a minus b the whole square. Now you take x power 100 and multiply each term. So that gives you integral 0 to 1 x to the power of 100 minus 2x to the power of 101 plus x to the power of 102 whole thing into dx. Now just do ordinary integration and substitute your limits. You get x to the power of 101 by 101 minus 2 times x to the power of 102 by 102 plus x to the power of 103 divided by 103, limits varying from 0 to 1. Upper limit will contribute because you will replace x as 1, and lower limit will not contribute because x is being replaced by 0. So the answer reduces to 1 by 101 minus 2 by 102 plus 1 by 103. Now you need not simplify this because normally these will be part A questions, which is just 1 mark or 2 marks questions. So ninth one is again a part A question. So you say evaluate integral minus pi to plus pi x square plus 2 into sine cube x dx. Whenever it's a part A question, that is just a 2 marks. Don't try to evaluate by substitution or using any integration techniques. All you try to do is an argument and see that if you can reply. Now x square plus 2 is an even function, and a sine cube x is going to be an odd function. Even into odd is always an odd function. Luckily, my limits are varying from minus a to plus a, so you can have a discussion of even and odd function. So when it says odd functions, I can rewrite this as the value. It will be 2 times 0 to pi if it's even function and 0 if it's an odd function. In this case, the integrand is odd function, and therefore the value of this integral will be 0, or you just write your answer is going to be 0 since the integrand is odd, and you get your full 2 marks question. Now next question is evaluate integral 0 to pi x sine to the power of 4x into dx. I change the limits here again. I use the limits and change my x. So that gives you I is equal to integral 0 to pi. Instead of x, I am using pi minus x. Sine to the power of 4 into pi minus x dx. Now sine 180 minus theta is in the second quadrant. Sine is positive and therefore it reduces to sine x itself. And so this gives me integral 0 to pi minus x into sine to the power of 4x dx. So add the two i's. So you get 2i is equal to x plus pi minus x. So x and x cancels to give you just pi into sine to the power of 4x dx. Pi is a constant, you can take it outside and change the limits. Sine to the power of 4x is an even function. So you change your limits as 2 times integral 0 to pi by 2. And you can use your reduction formula directly. And that formula, if integral 0 to pi by 2 sine power n x dx, your formula will be n minus 1 divided by n into n minus 3 by n minus 2, etc. So you're using that particular formula here to get it as this was 2i is equal to 2 pi, so the 2 and 2 gets cancelled. So I is equal to pi into n is 4, so n minus 1 by n will give you 3 by 4 into half into you add a pi by 2 because it's an even function, and therefore that reduces to 3 pi square by 16. We stop all the definite integrals here because all the other problems will be of the similar models. Thank you for listening so far about definite integrals.